All right, guys, we're going to take a quick look at exponential equations. So again, exponential equations are just equations that have exponential terms in them, okay? So if we want to fill this in here, right, an exponential equation is simply an equation where the exponent, right, the exponent is the variable. So let's take a look at the problem below here. So it says, what is the value of x? And you'll notice that this first one's 3 to the x, the next one's 3 to the 4th. They're the same basis, right? So the only difference is in the exponents. So if you're asking what does x need to be to make them equal, you really just take those exponents and you'd say x, well, x has to be 4. Now that's obviously a very simple example, okay, but that's really all we're doing with exponential equations here, okay? So in order to solve an exponential equation, we just have to make sure that the bases, okay, so in the example above, the 3's are the same. And once we do that, once we have the same bases, all we need to do is set our exponents equal to each other and solve. So let's use this really simple example down below, 2 to the x equals 4, to really illustrate that. So 2 to the x equals 4, what does x need to be to make those two sides equal? It's so simple you probably could do it in your heads. But let's use this idea of equating the exponents once we have the same base. So you'll notice 4, right? Not the same base as 2, but could you think of a way to rewrite 4 such that it has a base of 2? Well, 4 can be rewritten as 2 squared. So what if I said 2 to the x equals 2 to the second power? Well then, now I have the basis of 2. X must be 2. I just set my exponents equal to each other. Let's take a look at number 2. 5 to the 2x equals 25. Now I want to look at this. How can I rewrite 25, the larger number, okay, as 5 to some power? You're probably smart enough to realize, oh, 25 is just 5 squared. So I could rewrite the equation as 5 to the 2x equals 5 squared. That means 2x has to equal 2, or x equals 1. If we take a look at number 3, we have 2 to the 3x minus 8 equals 8. I would ask you or encourage you to pause the video and see if you can rewrite 8 as 2 to some power, and then go through and see if you can solve for the value of x. It's going to be kind of a messy fraction, but see if you can get that. All right, so hopefully you've paused it and have seen how it's played out. Let's see how it works out here. The left side is 2 to the 3x minus 8. The right side, 8, can be rewritten as 2 to the third power. So I have 2 to the 3x minus 8 and 2 to the third. That means that 3x minus 8 has to equal 3, right? Those exponents have to be equal to each other. If I add 8 to both sides, I'm left with 3x equals 11, or x equals 11 over 3. Not so bad, right? If we take a look at number 4, this is a little tricky. Both of them now have variables in the exponents. And trying to rewrite 27 with a base of 9 is actually not something that would work out very easily. So number 4 is a little different, in fact, in the sense that we would want to rewrite both the 27 and the 9 such that they have a common base. So can you think of any number that I could either square or cube, etc., that would result in 9 and 27, right? Obviously, you'd be raising them to a different power, but can you find any common base between 27 and 9 is probably a better way to say it. Well, if I think of 27 here, that's really 3 cubed. So if I rewrite 27 as 3 cubed, remembering to put that in parentheses, I could think of 27 to the x plus 3 as 3 cubed to the x plus 3. And I could think of 9 as 3 squared to the x minus 1. So notice, all I've done is rewrite 27 and 9 so that they have a common base. And if you remember from your Algebra 2 days, how can I break those exponents above the 3's out of the parentheses? Well, when you raise an exponent to something else, like we're raising 3 cubed to the x plus 3, what you do is you multiply the exponents together, and remembering to distribute. So I could rewrite 3 cubed to the x plus 3 as 3 to the 3x plus 9, and I could rewrite 3 squared to the x minus 1 as 3 to the 2x minus 2. Now that they have the same base, and I've broken them out of the parentheses, I can just set the exponents equal to each other, such that I could say 3x plus 9 equals 2x minus 2. If I move the 2x to the left side and the 9 to the right side, I get x equals minus 11. So looking at number 5, I would encourage you again to pause the video. See if you can rewrite 8 and 4 such that they have a common base. What common base would exist between 8 and 4? So pause the video for a second, see if you can solve for x, and then hit play and see if you get the same answer I do. All right, so for this one, I'm seeing 8 and 4 common base of 2. So I'm going to rewrite 8 to the x plus 2 as 2 cubed to the x plus 2. And I'm going to rewrite 4 as 2 squared to the x minus 3, and I'm going to distribute. So we get 2 to the 3x plus 6 equals 2 to the 2x minus 6. Again, remembering to distribute. Probably the number one mistake is forgetting to distribute. In this case, 3x plus 6 equals 2x minus 6. If I, again, move the x's to the left side and the numbers to the right, I get x equals negative 12. Okay? So when we think about, if we go to the next page, some practice here with these exponential equations. Again, all we're going to be doing is trying to find the same base. Now, 1 through 5 are a little bit tricky. Okay, they're maybe a little bit different. I'd say 3 is straightforward. Okay, 2 is straightforward. 1, 4, and 5 can be a little bit tricky. Okay, my hint on 1 might be, how do you get 1 from an exponential function, right? What would you need to raise 4 to get 1? Now, you might have an inkling about that, maybe you don't, but think, what do you need to raise 4 to get 1? And that might help you think about that. For number 4 and number 5, I might think about, how do you combine terms with the same base? And you might remember, if you combine terms with the same base, you add the exponents together. So keep that in mind, and also think about, how do you rewrite 1/10, okay, as 10 to some power, right? How would you think of 10? 10 to what power is going to equal 1/10? You might have to look on the negative exponent territory for that, okay? So part of your homework is doing these 1 through 5 here. So that's part 1 of your homework, okay? If you want to pause the video and do it now, you can. I'm going to go on to the second part, okay? The second part, which is, what do we do in solving an exponential function if we can't rewrite the base? Rewrite the base so they're the same thing. So take, for instance, 4x to the 15th, or sorry, 4 to the x equals 15. I cannot rewrite 15 as 4 to some power, right? 4 to the 1 equals 4. 4 squared equals 16, right? So raising 4 to some power to get 15 doesn't work. So how do I actually solve for x, okay, if I can't do that? Well, it's actually very easy if you know how to log roll, if you know how to solve for x. So in this case, all I'm going to do is take this equation, 4 to the x equals 15, and log roll it. And if you remember how to log roll, it was x, okay, log solves for your exponents, equals log base 4, so that's where this comes from, of 15, okay, equals x. So x equals log base 4 of 15. I've now solved for the exponent. Now you might be saying, well, Mr. Bodner, what is log base 4 of 15? Well, we don't know what that is. It would come out to a decimal. But the nice thing is, log base 4 of 15 is a number. There is some number we could simplify log base 4 of 15 to. We don't know what that is, but frankly, I don't care right now. All I want to do is isolate x. If we had a calculator, the calculator could tell us what log base 4 of 15 is. Okay? So in this case, all we had to do is just flip it into log form and leave it that way. You may feel uncomfortable with leaving it as log base 4 of 15, But it's the same way, or same idea of leaving something as, x equals 2 to the 3.1, right? 2 to the 3.1 would result in a number. We just don't know what it is, so we're kind of leaving it in that form. Obviously, we're not leaving it in exponential form. We're leaving it in log form. But it's that same idea that it's equal to some number, right? And so as long as we say x is equal to some number, then we're okay with that. So let's take a look at this one. 2 to the x minus 1 equals 7. First thing you always want to try to do is see if you can equate the bases. Again, change 7 into 2 to some power. Well, you probably can quickly realize that you can't do that. So if you cannot equate the bases, then we're going to log roll. So in this case, if I'm log rolling it, I know my exponent goes on the left side, so x minus 1 equals log with a base of 2 of 7. Now again, I want to isolate x, so I'm going to add 1 to both sides. X equals log base 2 of 7. Notice I put 7 in parentheses, plus 1. You can't add the 1 to the 7 and say 8, right? Order of operations would say you have to do this log function operation, this log base 2 of 7. You have to calculate that value first and then add the 1 at the end. So the reason we put the 7 in parentheses is to really indicate that that the 7 is inside the log and the 1 isn't. Okay, let's do a couple examples together. Okay, and then that's going to be it. So 3 times 2 to the x equals 15. Before you can log roll it, you have to isolate that expression, the 2 to the x. So what we're going to do is divide both sides, okay, by 3. If you do that, we get 2 to the x equals 15. Excuse me, not 15, 5. Let me fix that. Equals 5. Okay, I cannot rewrite 5 such that it has a base of 2. And now since that exponential expression is isolated, I'm going to log roll it. So I would say x equals log base 2 of 5. Okay. Now I'm sure you're already looking at 3 and saying, oh God, I don't know what to do. It's actually pretty straightforward. I'm going to do this one with you, okay? It's e to the x equals 1.8, okay? Now you may be tempted at first to say, oh, log expression's already isolated. I'm just going to log roll this and say x is equal to log base e of 1.8. Technically, I guess maybe you're right, but math, right? We don't write log base e. What do we write instead of log base e? We write ln. So actually, I'd want you to write it as x equals ln of 1.8. Means the same thing, but we just write it as, okay, ln. I mean, maybe the way I could equate it is, right, the ln of 1.8, I would consider that in uniform. Log base e of 1.8, you're not in uniform, okay? So just keep that in mind. Okay, when you see a base of e, like we see here, you want to change it into ln form, okay? So for the second part of your homework, I just want you to do problems 2 and 4. Make sure to isolate the exponential term, so add things to both sides, etc. Then log roll it, and then if you need to do more to get x totally by itself at the end, you can do so. Okay, so that's it for exponential equations. We have 2 forms. Just to summarize, the first thing you want to do is see if you can equate the bases. Okay, and once you do that, if you can equate the bases, set the exponents equal to each other. If you cannot do that, like we saw here, then you want to isolate that exponential expression, the exponential term, and then log roll it. Okay, good luck.